but so here you can see a full flow of all the process or all the components, all the interaction of the components. Okay, but let's see the code. Let's see the right. Let's see the front end first. The front end was implemented with Next. This was my first time with Next.js. I find it very helpful. I like it because it's very easy to set up a real project and start coding. No, so I create an application. This is very simple. I create this is the first page, and in this page, as I explained it, I used WebMe and Rainbow Kits. WebMe Rainbow Kits give me the connect button and help me to connect my wallet to the application. And this is a hook that I create. This hook help me to set the address. So the state of the application have a state that is the address, and when you connect your wallet, this state is updated with the wallet address, and this hook is for that. So this hook use this hook use set the address state in the application, and it update this address state when the application, when the MetaMask is connected. Just so, all right. And there are another states like the balance. It is the link to my official web page. Well, this is the WebMe Rainbow Kits provider, alright, with the connect button. This is the wallet component and the transfer component. So this is when this is the diff with the address input and the get balance button, and this is the transfer the transfer session with when you input the amount that you want to transfer and the address where you want to send the units. All right, and these components are in the components folder. So the wallet component is a wrapper of the address input component. So the address input component is so it is it have the address input and the get balance button, and this component have a state that is if the public key, if that you write in the input is a valid public key or not. So you don't need to connect your address to this application. You can use write your address in the input address component. It will work. This is okay. You don't need to connect your address, but after that I have not implemented yet the option of sign your message using a private key. So I have implemented right now the option using MetaMask. So you will need using MetaMask to do a full flow of the project. Okay, here is a user thread that is it is reset when the address change, and it just check if the public key is valid or not. Here is a function that is executed when you click the get balance button, and this function verify if the public key is valid or not, and it called the server, sending so asking for the balance of the address. All right, so this is the input with the when you write your address, and the button when you click the get balance. So this is for check if the public key is valid or not. This is a simple checking. I need to do this to use a regular expression. Actually, I use doing a splitting for the x, checking so simple things. Alright, and this is the address input component, and in the transfer component we have some states: the state of the amount, the state of the address that where we will send the units, and well, this state is not used right now because this functionality is not implemented yet. So we have as the hook that check that if the MetaMask wallet is connected or not. This is the function, the layer that is started when you click the transfer button, and this layer. So this is the template. This template you have an input when you write your amount, and another input where you write your destination address. And when you click the transfer button, the transfer function is executed. This function will create this message, and this message is like a transaction. This message have the from address, the destination address, the amount, the timestamp, and the nodes. If the wallet is connected, if the MetaMask is connected, we will do a call to send message. So send message is a hook from WebMe, and this hook use open MetaMask and show you the message that you need to sign. When you click the sign button, the unsuccess signature function is executed, and this function get the message, and the headers will be use the signature, this design message. This function will send this message with the signature of this message to the backend. Alright, just that, and it will set, so the backend respond with the balance. This function will update the balance in the application state. All right, let's see the backend. So the backend is very simple. It have used I implemented this using Segwalize, but it is not necessary. So you don't need to use Segwalize to implement this. And I decided to use Segwalize because I have the idea to implement a server using Rust, another server using Golang. Maybe I want that the information of one server will be sharing with another service, and I am thinking to use Segwalize and Docker volumes to do this. All right, but it is not necessary to use Segwalize. All right. The Segwalize model are here in this folder. So this is a generated code, and so you can see that the account model have an address that is of string, and have a balance that it is a begin. All right. There are the transaction model that have a timestamp, anonymous, from address to address, amount, and a status. All right. All right. This server have two endpoints. One endpoint for get the balance of one address, and this endpoint use search in the database for the account that you are asking for, and if the account exists, it will return the balance of that account. But if the account does not exist, it will create this account with 50 units of money, and it will return this balance. All correct. So this is the agate, and the second endpoint is a post, and it is executed when you do a send, and this endpoint use check the message properties. In this case, the signature, the front address, the to address, the amount, the timestamp. So this code just check the existence of the message properties. If the to account, so it after that is it search for the to account and for the front account. If the front account does not exist, it will create one with 50 units. And it will create a transaction object, and with the message data. So after that, we will verify if the message was signed by the person that sent this message. No, we will verify if the signature match with the message. All right. This code use verify that the signature is the message. Okay. This code behind the same will recover the public address from the signature, and will decrypt the signature, and will perform So a match over the message are the decrypted signature. So after that, we will check that the derived address from the signature is the same as the from address. And after that, we will check that the uniqueness for, for the nodes. So we will check that the nodes is unique for all the transactions that you send. This is for avoid replay attacks, and this is for check that the person that signed the message is the owner of the from address. Alright. And after that, we will check the timestamp, and we will check that you have enough funds for move or send the money. And after that, we will use subtract and add the money, and save the transaction and the modification of the accounts, and send back the from address balance. Alright, this is everything. This is all the code. It is very simple, so this is very easy to do. So let's note something important here. It is some code that it is not used. Alright, this code is not used, and this code is not used. Alright, I keep it here because I started using Ethereum cryptography, but after that I changed to EtherJS, and right now I do not use this code. Alright, but I decided to keep it here because this code can be used for decrypt some signature from the front end, extract the public key, and verify that the signature match with the message, that the decrypted signature match with the message. All right, so this code, I think that it can that I will use it in the future for the implementation of the feature that will be used to sign the message using the private key. All right, the idea is that you can write your private key in the front end and sign the message using this private key, and using this code in the backend, you can decrypt the signature, extract the public key, and verify that the decrypted signature match the message, and that it was signed with the private key, with the correct private key. Alright, but right now this code is not used. Alright, but is used here.